There are some problems on this sheet that we're going to use the same strategy for, but again, they have a little bit of tricky wording. And these are the ones that are circled. Number 6, 7, 8, 9, 11, and 14. In the other problems, we are told that the sum of the ages is a particular number. And so we use that last column that we had to set up an equation wherein we added the two expressions and set them equal to a number that was given to us. In these that are circled, there's a little different wording. So we're going to look at number 8. I'll go to a new page. And we're going to look and see what the wording is that's different. Anne is 18 years older than her son. 1 year ago, she was 3 times as old as her son. How old are they now? So the difference here is once we get to either moving into the future or the past, instead of telling us what the sum or the difference of their ages is or was, they are using similar wording with this as old as, twice as old as, let's see, 3 times that of. So again, we want to use the same strategy that we used for this type of thinking up here. But we're going to start out the same way. So with number 8, I'm going to start out with the first part that I'm given, the same way I did the other problems. So Anne is 18 years older than her son. It makes sense that the son would be the younger. And then Anne is going to be the age of her son plus 18. So this is going to be x plus 18. The son doesn't have a name, so we're just going to call him son. So we're going to set up our table. And input the information that we have up to the point where we have the bolded words. So we know that the son is our variable x, and that Anne is 18 years older than her son. And that is their ages now. In number 8, remember we stop 1 year ago. This is going into the past. So instead of being an addition, we're going to be subtracting, and we're going to be subtracting 1. So we're going to subtract 1 from Anne's age, x plus 18 minus 1, and we're going to subtract 1 from the son's age, x minus 1. So this is 1 year ago. This is how old they are now. This was 1 year ago. Now I'm going to look at my wording again that comes after this phrase 1 year ago. She, meaning Anne, was 3 times as old as her son. So there's this phrase again, as old as. And what that keys into us is that whatever operation precedes that or comes before it, when we write it down, we want to apply this operation 3 times to the value of the son. So that means if we take the son's age and we multiply it by 3, we should get Anne's age 1 year ago. So when we look at what we have 1 year ago, this is what we have. This is 1 year ago. This is where we want to focus. And we know that the son's age right here is, Anne is going to be 3 times as old as her son is right here. So if we multiply this by 3, we should get Anne's age, which means that we can take these two expressions and simply by multiplying this one by 3, we should be able to set them equal to each other. But we have to multiply this one by 3 first. It makes sense that Anne would be older. So we're going to take the son's age and multiply it by 3 to get it equal to Anne's age 1 year ago. So I'm going to take this expression and this one and set them equal to each other. Now I'm going to combine like terms here because I know that 18 minus 1 is 17. And that's going to be equal to not x minus 1, but 3 times x minus 1. Now I need to use the distributive property and distribute my 3 through my parentheses. So I'm going to have x plus 17 is equal to 3 times x is 3x, and 3 times a negative 1 is negative 3. Now I can start moving things around and trying to isolate my variables on one side and my numbers on the other. Well, I can see in this expression I have 3 x's, and over here I have 1 x. So I'm probably going to want to have my x's on the right-hand side. That would be simpler. So first I'm going to get rid of the negative 3 on this side by using the inverse operation and adding 3 to both sides. That cancels these out, and it gives me x plus 20 on this side and 3x over on the right-hand side. So now I have only x's on this side, but I want only numbers on this side. So to do that, I'm going to subtract an x from both sides. If I do something on one side, I can do the exact same operation on the other side. So this is going to take me down to no x's, 0 x's. I'm going to be left with 20 on the left, and 3x minus x gives me 2x. So now I want to find out what 1x is equal to. Remember, this is a multiplication problem, so to undo the multiplication, I do the inverse and I divide by 2 on each side. That's going to cancel out my 2's on the right, and I get x is equal to 10. So when I look back up in my problem, the son was 10 years old, if I'm correct, and Anne should be the son's age plus 18. So that's 10 plus 18, and that would equal 28. So if my answers are correct, these are their ages that they are now. But let's check it. They told us that 1 year ago, so let's do 1 year ago, the son, if I take away 1, is going to be 9 years old. And if I take away 1 year from Anne, I get 27. And I can see that Anne is 3 times the son's age. The son is 9, and 9 times 3 does equal 27. So it looks like my answer for this problem, let's see, they want to know how old are they now. It looks like now the son is 10 and Anne is 28.